Welcome again, grade 6, for another fun, exciting, and engaging math class. Again, I am your Ma'am Kat. I will be your virtual math teacher today. Hope you will learn and enjoy the lesson today. At the end of this lesson, you will be able to formulate the rule to find the nth term of a sequence. Look at the calendar here. Look at the circled number in our calendar. We have 4, 8, 12, 16, 20, 24, and 28. Have you noticed a pattern in this circle number? This is called a number sequence. A number sequence is a list of numbers in which successive terms follow a rule or a pattern. Each number in a sequence is called a term. In our example, the terms here are 4, 8, 12, 16, 24, and 28. Let's go back with our calendar a while ago. Look at the circled number here. If we take two of the successive terms of the circled number in our calendar here, you will see that the difference is 4. Example, we take 12 and 8. And 12 minus 8 is 4. And also, if we add 4 to the previous term, we will get the next term. Example, we have 8 is the previous term, plus 4, the second term is, or the next term is 12, because we have 8 plus 4 is 12. Therefore, the rule in the sequence 4, 8, 12, 16, 20, 24, and 28 is adding 4 to the term before it. Let's have an example. Now, let's find the rule for this sequence, and also let's find the next 3 terms for this sequence. Example, the sequence 3, 6, 9, and 12. Look at the sequence here. Every term is obtained by multiplying 3. Example, in our first term, that is 3 times 1, so we have 3. The second term, we have 3 times 2, that is 6. And the third term is 3 times 3, and that is 9. The fourth term is we have 3 times 4, and that is 12. Therefore, the nth rule for this term is 3n, or 3 times n, where n is the nth term. Example, we are looking for the next 3 terms of the sequence. We are looking for the 5th term. So we have the 5th term is equal to 3 times 5, because we are looking for the 5th term, and that is 15. Next is the 6th term. We have 3 times 6 is 18. And the 7th term, we have 3 times 7, we have 21. Therefore, the next 3 terms of the sequence are 15, 18, and 21. Let's have another sequence here. we have 1, 4, 9, 16. Look at this sequence. The terms are obtained by squaring the counting numbers, or the counting number starts with 1. Example, we have here the first term. The first counting number is 1, so we have 1 squared, or 1 times 1. The answer is 1. The second term here, 2 squared, and that is 2 times 2, which is equal to 4. And we have the third term, that is 3 squared, and that is 3 times 3, that is equal to 9. We have the fourth term, we have 4 times 4, or 4 squared, and that is equal to 16. So therefore, the nth rule for this term, or for this sequence, is n squared, or n times n, where n is the nth term. Now let's look for the next 3 terms of this sequence. The fifth term. We have the fifth term is equal to 5 squared, which is equal to 5 times 5 equals 25. And the sixth term, we have 6 squared. 6 times 6 is 36. And the seventh terms, or the seventh term of the sequence, we have 7 squared, which is 7 times 7 equals 49. So therefore, the next 3 terms of the sequence are 25, 36, and 49. And the rule for the sequence is n squared, or n times n. Let's have another example. We have here the sequence 2, 3, 4, 5. Now, you have noticed that each term in a sequence has a difference of 1. For example, in our first term, we have 1 plus 1, that is 2. The second term, we have, since we have the second term, we have 2 plus 1 equals 3. The third term, we have 3 plus 1 equals 4. In the fourth term, we have 4 plus 1 equals 5. Look at this pattern. So you see that the pattern here, we just add 1 to the term. That is why the n-term rule for this sequence is n plus 1, where n is the nth term. Now let's take the next 3 terms of this sequence, which are the 5th, 6th, and 7th term. Applying the rule, we have n plus 1. The 5th term is 5 plus 1 equals 6. The 6th term is 6 plus 1 equals 7. And the 7th term is 7 plus 1 equals 8. So therefore, the next 3 terms of this sequence are 6, 7, and 8. Following the nth rule term, or the nth term rule, which is n plus 1. Let's have another sequence here. We have 2, 4, 6, and 8. Looking at the sequence, you have noticed that each term in a sequence has a difference of 2. Therefore, the first term here, we have 2 times 1, which is 2. And then the second term, we have 2 times 2, that is 4. The third term is 2 times 3 is 6. And the fourth term, we have 4, or 2 times 4 equals 8. Therefore, looking at this pattern, they are all multiplied by 2. Therefore, the nth term rule for this pattern is 2n, or 2 times n. let's have another sequence. We have here 3, 1, -1, and -3. So each terms in this sequence is obtained by subtracting or by adding -2 to the number before it. Every term after the first term of this sequence is obtained by adding -2 to the number preceding it. For example, we have the first term, which is 3, and the second term we have 3 plus -2 equals 1. The third term is 1. Since our second term is 1, we use 1 plus -2, and that is -1. And the fourth term is -1 plus -2, and that is -3. Now let's have another example where we use the working backwards. Here the sequence 2, 5, 8, and 11. So when we are working backward, we use the last term, which is 11. So we have here the third term, which is 11 minus 3 is equal to 8. So therefore the third term is 8. While the second term, we have here 8 minus 3 is 5. So that is working backward. Working backwards, you will notice a pattern that subtracts 3 to get the next term on the left. Now, think of a way on how you will get each term of having a common difference of 3. Let us use another strategy to get the nth term rule for this sequence. We will be using the same sequence, which is 2, 5, 8, and 11. Now, I have here a table. The table has 3 columns: the guess, check, and conclusion. Now, let us guess. Let's try 3 times n plus 1. Is this rule correct for our sequence? Let us check. So we have here 3 times 1 for n. We're looking for the first term. We have 3 times 1 is 3 plus 1 is 4. So the answer is 4 for the first term if we are going to use this rule. Now, the conclusion is the rule is wrong because the first term in our sequence 2, 5, 8, 11 is 2 and not 4. Now, let us have another guess. Say that the rule is 3 times n minus 2. Let us check. We have 3 times 1 minus 2. 3 times 1 is 3 minus 2. The answer is 1. So what is the conclusion? This is also wrong. The first term is 2 and not 1. Next, let's have our third guess. Our third guess is 3 times n minus 1. Let us check. We have 3 times 1 is 3 minus 1 is 2. Now, let's conclude. The rule is also exact for the other 3 terms of our sequence. Therefore, the correct rule for this sequence is 3n minus 1. This is correct. Our third guess is correct. Let's have an activity. Study the figure here, and you will draw the next figure. And then you will try to write the term rule or the nth term rule for this figure or for this sequence. So we have the first figure, the second figure, the third figure, and you will guess the next figure. Now, I'll give you time to answer this. Alright, time's up. This is the next figure for this sequence. Now, what is the nth term rule for this figure? We have the rule, the nth term rule, we have 1/2 n times quantity n plus 1. We have 1/2 of 4 is 2, and 4 plus 1 is 5. So 2 times 5 is 10. So the answer is 10. How about the arithmetic sequence? What is the arithmetic sequence? Arithmetic sequence is a sequence which has a common difference, or each term has a common difference. Example, we have 2, 4, 6, 8. It has a common difference. It has a common difference of 2. And also we have here 3, 6, 9, 12. It has a common difference of 3. We have the last example, we have 7, 12, 17, and 22. It has a common difference of 5. And to get the common difference, you just need to subtract the second term and the first term. So that is how to get the common difference. And that is the arithmetic sequence. Let's know more about the arithmetic sequence. There is a formula that we can use to find the nth term rule and the next term or the nth term of an arithmetic sequence. So that formula is a sub n is equal to a sub 1 plus quantity n minus 1 times d, where n is the nth term and a sub 1 is our first term and d is the common difference. Now let's go back with our previous example, the sequence 3, 1, -1, and -3. Let's use the arithmetic sequence formula to find its nth term rule. In our sequence, we are going to look for the nth term rule. We have a sub 1, or the first term, is 3, and the n is the nth term. Common difference for the sequence is -2. Now, let's substitute the value. And then, let's simplify it. We have here 3 plus quantity n minus 1 times -2. So this -2 will be distributed to n and minus 1. So we have here 3 plus -2n plus 2. Let us simplify it. We have here plus 2 and 3, so we get 5. That is -2n plus 5. Or we can write this as 5 minus 2n. So this is the nth term rule for this pattern. How about if we are going to look for the nth term of a sequence? Example, you are looking for the 101st term of the sequence. Or if you are going to look for the 99th term, 1000th term of the sequence, that's very hard. But we can use the geometric sequence formula. Example, let's look for this example. Find the 51st term of the sequence 6, 9, 12, and 15. Now, using the formula, We have a sub n equals a sub 1 plus quantity n minus 1 times d. In our sequence, our n is 51 since we are looking for the 51st term. And our a sub 1 is the first term, which is 6. And the common difference is 3. Now let's substitute. Let's substitute the value. We have a sub 51 equals, the first term is 6 plus quantity 51 minus 1 times 3. So now we are using the Gemdes rule, which is inside the parentheses. So we have a sub 51 equals 6 plus 50 times 3. And now we multiply 50 and 3. We have 6 plus 150. Therefore, a sub 51 is equal to 156. The 51st term of this sequence is 156. Let's have another example of finding the nth term of a sequence. Now, let's take this example. We have 7, 11, 15, and 19. We're going to use the formula a sub n is equal to a sub 1 plus quantity n minus 1 times d. And we are going to look for the 32nd term. Now, substituting the value, we have a sub 32 equals, the first term is 7 plus quantity 32 minus 1 times the common difference of 4. Now, let's simplify. We have a sub 32 equals 7 plus 31 times 4. And then we multiply 31 and 4. We get a sub 32 equals 7 plus 124. So 7 plus 124 is 131. Therefore, 32nd term of this sequence is 131. Before we do our final activity, let's have a review. Now, what is a number sequence? A number sequence is a list of numbers that follows a pattern or rule. How about what are the two types of sequence? We have the geometric sequence and the arithmetic sequence. Geometric sequence is a sequence that having a common ratio, while arithmetic sequence is a sequence or a list of number that has a common difference. Now for your final activity, you're going to find the next 3 terms of these sequence. Now I'll give you time to answer this. Time's up. These are the answer for activity. Hope you got the correct answer, grade 6, and hope you enjoy our lesson. And I think it's already time. It's the last part of our class today. Hope you enjoy and learn in our lesson today. And I'll leave you again the saying, I will not tell you the answer, but I'll give you the way to find the answer. Again, I'm your Mom Cat, saying goodbye.